Okay, this is going to be 6.2. 6.2, the authors cover properties of numbers. Okay, these are all things that you've been working with pretty much your entire life. So we're not going to go into this in a whole lot of detail. I'm going to assume you kind of know it. But let's just kind of hit it quickly just to make sure we've covered all the material in the book. Remember, we talked about a number line last time. Okay, if you add two numbers together, what does that amount to doing? 3 plus 4? Let's go one more. That means you start at 3, or actually you could start at the origin and say you first go 3 units, 3 positive units, and then you go 4 more, 1, 2, 3, 4, and you end up at 7. That's the easiest way to think about adding numbers. If you have -2 plus a -1, that'll be, you start at the origin, you first go -2, and then you add a -1, which means you go to the left one more unit, and that's going to be -3. Okay? If you have 3 plus a -5, what does that do? It means you start at the origin, you first go 3, now you go a -5, so it's going to be 1, 2, 3, 4, 5. So you add up, you end up at -2. 3 plus a -5 is the same as saying 3 minus 5. Okay? If I have -2 plus 5, what's that going to give me? I start here, I first go -2, and then I add a positive 5, 1, 2, 3, 4, 5. I end up at 3. Okay? So that's just a matter of adding numbers. Okay, then let's talk about multiplying numbers. What if I have 7 plus 7 plus 7 plus 7 plus 7? I could write it out that way, but it's kind of cumbersome. I'd rather just say I have 5 7s that I'm adding together, and the way we write the fact, or we express the fact that we have 5 7s, is to write 5 times 7. You can either write it like that, or you can of course just put it in parentheses like that, and either way you get 35. Okay, you can also use a little times in between there, but you typically don't do that because we often use a little symbol like this for x. So usually we write it either like this or this. Now, you can also have, that's 5 7s. What if you have 7 5s? 1, 2, 3, 4, 5, 6, 7. What does this add up to if you were to add all those up? That's 7 5s, and it turns out that that's also 35. Is that just a coincidence that if I take 7 times 5, I end up with the same as 5 times 7? Is that a coincidence, or is there some way to prove it? And you've probably multiplied numbers enough together over the years that you know it's not a coincidence. And the reason why it's the case, you can easily see by just making yourself a grid. If you make a grid with 1, 2, 3, 4, 5 rows that way, and 1, 2, 3, 4, 5, 6, 7 that way, then here I have 5 plus 5 plus 5 plus 5 plus 5. I have 7 5s there. And here, looking at it this way, I have 5 7s. I have a 7 here, 7 here, 7 here, 7 here, 7 here. So I have 5 times 7. And either way, whichever way you express it, you notice you still get all of those squares, so either way you get 35. So that's why 7 times 5 is equal to 5 times 7. Okay? If I take -7 plus -7 plus -7, then we already know how to add. That's -7. You have 3 of those. And so by the time you're done, you're going to get 3 of those -7s, and that's going to give you -21. And since we want this to be either order, then it's also got to be the case that if I take -7 times 3, I'm going to get -21. So it doesn't matter which, positive or negative. When you end up with one negative times a positive, you end up with a negative. What if you have a negative times a negative? What's negative 1 times negative 1? Okay? It's kind of like saying, I'm going to make bread. I'm not going to make bread. And then someone else might say, I'm not going to make bread. If you're not going to make bread, that means you're going to make bread. So if you take two negatives and put them together, you end up with a positive. So there you are, back up to a positive again. So now we know that if you take something like a negative 5 times a negative 7 again, well, one way to think about it is this is negative 1 times 5 times another negative 1 times 7. And we already said that when you multiply numbers, you can change the order. So if I want to, I can take the 5 times 7 and get 35. I can take the negative 1 times the negative 1, and that gives me 1. And so I just end up with a positive 35. So a negative times a negative gives you a positive. Again, these are things I assume you've seen before, so I'm not going to go over it real slowly. You spent a lot of time learning this back in the, 5th or 6th grade probably. Okay, so anyway, that's multiplication. Okay, what about division? What does 12 over 3 equal? 12 over 3, you can think of it as 12 thirds. If you have thirds of a pie, and I have 12 of those, there's 12 thirds, and so that gives me 4 pies. So 12 over 3, you can write 12 as 4 times 3, and this is 3 times 1, and the 3's divide out, and you just end up with 4. Okay? So another way to think about it is 12 over 3 is equal to 4 is true because 12 is equal to 4 times 3. Okay? So this times this gives you that. 20 over 20 over 2 is equal to 10. Why is that? That's because 20 is equal to 10 times 2. Okay? Now, you might have heard before that you can't divide by 0. I said it myself just a little bit ago. Why is that? Well, 5 over 0 is equal to, what are you going to set it equal to? What should we set it equal to? What can that be equal to? Whatever that is equal to, what's got to be true? It's got to be true that 5 is equal to that number times 0. What is it that I can multiply by 0 and get 5? And you see it's impossible. It's impossible. So this thing here, or 0 over 0, either way, anything divided by 0 just makes no sense. And so that's why we say we can't divide by 0. It just doesn't make sense. Okay? If you have 24 over 16, you can get that. Another way to express that is you can write 24 as 2 times 2 times 2 times 3, right? That's 8 times 3. 16 is 2 times 2 times 2 times 2. And then these all divide out, and I end up with is equal to just 3 over 2. And again, I'm doing this fairly quickly because I assume you've seen this before. When you're multiplying numbers like this, you can just cancel them out. On the other hand, if you have 2 plus 3 over 3 plus 1, okay, there you cannot just cancel out the 3's. This is equal to what? 5/4? That's equal to 5/4. If you were to cancel out the 3's, what would you end up with? You'd end up with 2 over 1, which is 2. 2 is not equal to 5/4, so we see with addition, you can't just cancel out numbers like that. But with multiplication, you can. Okay, multiplication is a little bit easier. Okay, very good. Okay, now in the same way that we said that 7 plus 7 plus 7 plus 7 plus 7 is equal to 5 times 7. Okay, that's true. What if we have 7 times 7 times 7 times 7 times 7? Is there some shorthand for that? Okay, it seems like we should maybe want it because we often have expressions like this in mathematics in the real world where you multiply a whole bunch of those together. So here's the notation. You make a 7 and you put a little 5 there in the exponent position. Okay, I'll just kind of go over this pretty quickly. 7 to the 0 power, for any number to the 0 power, is equal to 1. And if I decide to divide by 7, like this, that's 1 over 7 cubed, and that you can write as 7 to the negative 3 power. So when you have negative exponent, that means it's 1 over that. Okay? And once you have those rules down, then you can see how to use them. For example, if you have 7 times 7, if you have 7 to the 5th times 7 cubed, what's that going to be equal to? 7 to the 5th is 5 of them. 7 cubed is 3 of them. You multiply all those together, and you get 7 to the 8th. So you see that you just multiply these exponents together. If you have 7 to the 5th divided by 7 cubed, what do you end up with there? 7, 7, 7, 7, 7, divided by 7, 7, 7. As we just said, you can cancel these out, and you end up with 7 squared. So notice that when you divide one thing by another, you subtract the exponents. Okay? So those are rules. Those are just kind of rules of numbers. Okay? Those are just rules of numbers. Okay, very good. By the way, if I had negative 7 to the 4th power, that's negative 7 times negative 7 times negative 7 times negative 7. Negative times negative is a 1. Negative times negative is a 1. So 1 times 1 is 1. So that's just going to be 7 to the 4th. Okay? So that is not the same. Let me just clarify this. It's not the same as negative 7 to the 4th power. Because whenever you see something like this, everyone agrees that you first do this, and once you do that, then you take the negative of it. So this would be negative 7 to the 4th power. And so this one is positive, that one is negative. Okay? Very good. Let's see. Anything else? In the book on page 243, the author spends a little time giving you all the properties of the real numbers. I think there's about 10 or 11 properties there, depending on how you count them. And if you take all those properties, which include some of the things we've already talked about, here's some of the others. If you take the real numbers, it doesn't matter which way you add them. You can add them in either order. If you have 3 things together, I can add those 2, or I can add these 2 first. Either way, I get the same thing. If I have some number times b plus c, that's equal to a times b plus a times c. Those are all the rules. This is called commutative property, associative property, distributive property. Okay, you don't have to know all those names, but the point is you should just understand how numbers work. And any collection of things that satisfy all these rules, this is something that you don't have to know, but I'll tell you anyway, it's called a field. A field is any collection of things that satisfy all the properties that real numbers have. Okay? And the last thing I'll just mention to you is, no, I'm going to wait. I'll wait with that until next time.